Have you ever wondered how we can better understand the issues and patterns around us? How can we interpret and, to some extent, predict certain events and trends? Get ready for an exploration of intriguing numerical laws and the mysterious strategy of the universe. Join us on a journey through the mathematical mysteries that help us to unravel the workings of our universe. Welcome to Mysteries and Theories.
Occult Mathematics, exploring the numerical laws and strategy of the universe. The Pareto Principle.
The Pareto Principle, also called the 80-20 rule, is a mathematical theory that seeks to simplify the understanding of certain aspects of our world. Let's explain how it works. Imagine you have a to-do list for the day. By applying the 80-20 rule, you would realize that 80% of your productivity comes from just the 20% of your most important tasks. This helps us focus our energy where it really matters, optimizing our time and resources. Here's another simple example. Let's consider an example related to time management and studying. Here are 10 things a student could focus on when preparing for an important exam. A list of 10 tasks starting with read course material and scroll down to use learning apps. Using the Pareto principle, it's possible that as much as 80% of your exam performance is influenced by the following two actions. This suggests that concentrating most of your time on these two activities can lead to a significant result in your exam performance, while the other activities are also important, but to a lesser extent. In the context of a business, the 80-20 rule can be applied to find that 80% of a company's profit comes from the 20% of its most important customers. Or on a project, you might notice that 80% of the problems are caused by the most complex 20% of tasks. In short, 80% of the results come from only 20% of the causes or efforts. Therefore, we can say that the Pareto principle is a realistic description of many situations. But remember that it may not be strictly true in all cases. The main advice is, focus on more effective activities or elements to achieve significant results with less effort.
Zipf's law.
Zipf's law is an interesting rule that is sometimes used to understand the distribution and frequency of a set of things like words in a book, songs in an album, or even cities in a country. This law says that within a set of things, the most frequent element occurs approximately twice as often as the second most frequent element, 3 times as often as the third most frequent, and so on. A little confused? Let's explain better. Let's imagine an example with words in a book. If the word house appears 100 times, the second most common word would appear about 50 times, the third about 33 times, and so on. This happens in many different situations, and it's a great way to understand how unevenly but predictably things are distributed. When analyzing the population of cities, you will notice that few cities have a very large population, like Tokyo or New York, while most cities have smaller populations. This follows the pattern of Zipf's law. Another example. In the music industry, some songs or artists are incredibly popular and dominate the charts, while many others have a lower level of popularity. This also fits the Zipf pattern. In internet searches, the most common or popular keywords have a much higher frequency, while more specific words tend to have fewer occurrences. And all of this occurs in proportion to the most popular being 2 times more frequent than the second and 3 times more frequent than the third, and so on. Zipf's law describes this uneven frequency distribution, where few elements have high occurrence and many have low occurrence. It can be applied in many areas, such as text analysis, city population, and market behavior, revealing patterns of inequality in the data.
The Benford's law.
Benford's law, also known as the law of anomalous numbers, is a surprising statistical discovery that reveals a curious pattern in the way numbers appear in many types of real-world data. This law says that if you take a list of numbers, such as prices, populations, or measurements, and look at the first digit of each number, you are more likely to see the number 1 inch as the first digit more times than any other number, such as 2, 3, and so on. For example, If you take a list of prices, populations, electricity bills, or physical constants, you will notice that the first digit of these numbers is not equally probable. In fact, the digit 1 appears much more than the 9, and the 2 appears more than the 8, and so on. Benford's law tells you how likely each digit is to appear, and it goes something like this. For example, if you look at the first few digits of city population numbers, it's more common to find cities whose population starts with 1, like 100,000, than with 2, like 200,000, or 3, like 300,000, and so on. And this is a pattern that repeats itself in various natural or social phenomena that involve growth or multiplication. This rule is useful for detecting strange or falsified numbers, especially in accounting and finance, where it can help to find errors or even fraud in the presented numbers. It's as if the numbers have a tendency to follow this magical rule, and the ones that don't can call our attention to something wrong. But unfortunately, Benford's law is neither infallible nor definitive. Other factors must be taken into account, such as the context, source, quality, and quantity of the data, as well as human limits, restrictions, or preferences. Don't miss the next episode where we'll explore the most mysterious theories about numbers. Subscribe to the channel and see you next time.